Have you ever wondered how many black pixels are hiding in your images? It might seem like a simple task, but counting pixels can get tricky, especially when you're dealing with a grid. Today, we're diving into the world of pixel counting on the GPU, and trust me, you won't want to miss this. I totally get it. You have a 128 by 128 pixel image broken down into an 8 by 8 grid, and you want to count the black pixels. It can be frustrating to think about doing this manually, especially when you know there's a more efficient way. You're not alone in this struggle. So, here's the specific question we're tackling today. How can we efficiently count the black pixels in this grid using the GPU? You mentioned that counting manually is straightforward, but you're curious if there's a better way to leverage the power of the GPU. Let's explore this together. To understand the issue, let's break it down. You have a grid where each block contains 16 by 16 pixels. Counting black pixels in each block individually could save time, especially if we can process them in parallel using the GPU. This is where the magic happens. And stick around. At the end of this video, I'll share a powerful tip on how to optimize your pixel counting process even further. You won't want to miss it. To begin counting the black pixels using the GPU, the user should first divide the image into smaller blocks. In this case, each block is 16 by 16 pixels. Next, the user can create a kernel function that will process each block in parallel. This function will check each pixel in the block to determine if it is black. After defining the kernel, the user should launch it with the appropriate grid and block dimensions. This allows the GPU to execute the function across all blocks simultaneously. Once the kernel has finished executing, the user can gather the results from each block. This will give the count of black pixels for each block. Finally, the user can sum the counts from all blocks to get the total number of black pixels in the image. In this example, the total would be 78 black pixels. Fun fact, the first GPUs were primarily designed for rendering graphics, but now they are powerful tools for data processing. Who knew counting pixels could be so high-tech? Now, let's look at the answers provided by other users. This user confirms that the GPU can handle your pixel counting task efficiently. They highlight that the numbers involved are very GPU-friendly, with a warp size of 32 and a maximum of 1,024 threads per block. They explain the general procedure for using the GPU, which involves copying data from CPU memory to GPU memory, performing calculations, and then copying the results back. However, they caution that this data transfer can be slow. The user also shares their opinion that for this specific task, the time taken to transfer the image to the GPU might exceed the time taken to compute the result using a single CPU thread. Finally, they suggest that if you find this pixel counting routine to be a bottleneck, consider using a divide-and-conquer recursive algorithm or parallelizing the calculations across multiple CPU cores. Let's take a look at an answer from another user. An alternative approach suggests leveraging the thrust library for efficient pixel counting on the GPU. This library includes a count function that uses a predicate to determine which pixels to count. For example, you can create a custom predicate to check if a pixel is black. Additionally, the user mentions that you could linearize your pixel data for easier processing. If you're interested in a histogram approach, you can sort the pixels and then use a reduction by key to count occurrences of each unique pixel value. Here's a pro tip. When working with GPU programming, always consider how to maximize parallel processing. This can drastically reduce your counting time and improve efficiency. And there you have it. You now know how to count black pixels in your image using the GPU. Remember, leveraging parallel processing can save you time and effort. If you found this video helpful, please subscribe for more tips and tricks on optimizing your coding projects.